Question number 28 CY 2022, and the question is the correct statements about thallium halides is or are. Option A, thallium fluoride is highly soluble in water, whereas the other thallium halides are sparingly soluble. Option B, thallium fluoride adopts a distorted NaCl structure. Option TLI3 is isomorphic with CSI3 and the oxidation state of TL is +3. And option D, both TLBr and TLCl have CSCl structure. So you have to choose correct statement or correct statements among all these options. Now coming to the answer. First, we will look into the option A. What is option A? Thallium fluoride is highly soluble in water, whereas other thallium halides are sparingly soluble. This statement, either it is right or wrong, we can say through the periodic trends of halides. Halogens are as follows. Okay. Halogens. So down the group, size increases and up the group, electronegativity increases. So two factors. One is electronegativity, that is if you go up it increases and fluorine is the highest electronegative element, and now if you go down the group the size increases because of the opening of new principal quantum number. So because of this lower electronegativity and higher size, down the group the polarizability also increases. This infers tendency to form covalent compound also increases. Thus, if you go down the group in halogen halides, they will form more. Thus, thallium fluoride is character among the thallium halides. Among very easily you can say, since it is the highest, it has the highest ionic character, the solubility in water is also highest. Thus option A, is correct. Now come option C. TLI3 is isomorphic with cesium iodide and the oxidation state of thallium is +3. Yes, the oxidation state of thallium in TLI3 is +3. But there is another factor. That is, you can see the compound CSI3. Cesium is group 1 metal. It forms only cesium plus N because to form cesium 3 plus, cesium has one electron in the outermost s orbital. It is very easy to knock out the electron to cesium plus ion. Now, and the s electron in cesium is situated in the 6s orbital, which is actually penetrated inside towards the uh, nucleus due to the low shielding effect of F and D electrons, low shielding effect of inner F and D electron. Thus, the formation of cesium 3 plus very high energy requiring, making the process highly endothermic, thus non-existing. Now coming to the TLI3. Now if you go to the periodic order of thallium, that is boron, aluminium, gallium, indium, thallium. Group 13. If you go down, size increases. Group 13 element, the group oxidation state is +3. But in case of thallium, +1 OS is more stable, and the reason is inert pair effect. Cesium has electron in the 6s2 orbital. Because of the low shielding of inner D and F orbital, the 6s orbital is penetrated inside towards the nucleus. Thus, to knock out that 6s2 electron from thallium is very difficult. Thus, the thallium, most of the time, it forms thallium plus ion. Thus, we can see that cesium-I3 is non-existing, and presence of TLI3 is also a difficulty because of the inert pair effect, where thallium gives more stable +1 ion to form TLI. Thus, option C, which is actually telling TLI3 is isomorphic to CSI3 and oxidation thallium, is actually wrong, and you can easily state the reasons. Now come to option B and D. So first is TLF add-off distorted initial structure, and TL CL have cesium chloride structure. Now, to know the lattice structure of inorganic crystalline compounds, we can adopt one formula through R plus by R minus values, which says if it is less than 155, then the molecule is linear. If it is 0.155 to 0.225, then it will acquire B2O3 structure. if it is 2.225 to 0.414, it acquire Zeroth structure. If the R plus R minus value, R plus by R minus value is in between 0.414 to 0.732, it acquired NaCl structure. More than 0.732 will acquire cesium chloride structure. Now in Pauling scale, the atomic radius order is thallium plus ion is 144, F minus is 136, Cl minus is 181, and Br minus is 195. Now if you calculate R plus by R minus of TLF, value would be 1.5 of TLCL, it is 0.7958, is 0.7384. Now this value is more than 732, so TLCL have cesium chloride structure. Now this value is on the borderline of NaCl and cesium chloride structure. Now in borderlines, both possibility is there that thallium bromide can acquire NaCl structure or it can acquire cesium chloride structure, but because of the higher size of bromine, to reduce inter-ionic repulsion, it is actually acquiring cesium chloride structure. Because of the bigger size of bromine, if we thallium bromide in NaCl structure, there will be high electronic repulsion between the bromine atoms, so it acquires a cesium chloride structure, which is actually BCC type lattice. Now the value of 1.0588, it actually is more than 1 acquires cesium chloride structure, but because of the smaller size of fluorine, if we put the TLF, the thallium ion and fluorine ion, in a BCC lattice in CHCl structure, then their interatomic attraction between thallium and fluorine will be less. Thus, in this case, thallium fluoride actually adopts distorted. The only reason is the size of fluorine. If fluorine size is small, and if in BCC lattice or CHCl structure, the atomic interaction between thallium and fluorine will be less, and packing efficiency also coming handy in this case. In case of thallium chloride and thallium bromide, packing efficiency will follow the structure of the compound towards the CHCl structure, and in case of thallium fluoride, the packing efficiency will follow the compound having NaCl structure, distorted NaCl structure. So both of this statement is correct. So your answer is, correct statement is A, B and D, and this is wrong. So answer is A, B, D. You can find the reference to Lecture on Group 13 Elements by Professor M.S. Balakrishnan, Department of Chemistry, IIT Bombay. Thank you very much.